We are live now.
Good evening to all. I, Mrs. Harleen, on the behalf of entire GCG family, welcomes you all in the day 4 of National Faculty Development Program on Research Methodology, organized by IQACSL GCG. And you to all the participants for your overwhelming response to the program. Feeling proud to share that the videos of day 2 and day 3 has even crossed 500 views. Thank you and congratulations to the team. It's rightly said, a good person is like a lamp who lights the path with his intelligence, experience, and knowledge. And we're lucky to have such person as the resource person for the program. Dr. Pavan Kumar, Associate Professor, Middle School Business, Lovely Professional University. He has the extraordinary power to explain a very complex concept in a very simple way. We welcome you, sir. Now, I request Dr. Pavan Kumar to kindly start the session, please. Over to you, sir.
Okay, thank you, Madam Harleen, for the nice brief introduction, and thank you for setting the tone for today. You know, as like in the concert, when the artists, sit on the podium, on the stage, they set their instruments. So in setting the instrument is very, very important, that how tuned are your instruments. So thank you for just setting the instruments and the stage and everything for today's session. Anyways,
Thank you,
so
sir.
thank you very much to everyone from the organizers of this FDP. And let's start with the, I had some queries yesterday. So I'll take first two queries that one of the the participant asked me, okay, sir, if I'm using the quantitative and qualitative data, so which sampling would be best for quantitative data? Ashima, your question is very good. So it depends upon your, type of the topic, the type of the research title, the research study you are doing, right? So that will actually tell you whether you are going to suppose the probability sampling or non-probability sampling. But Ashima, what you can do, you just look at your topic and you just see whether, I mean, the sampling frame is possible or not. If the sampling frame is possible, then I think you go for the probability sampling, which we can call it as also a random sampling. But in case if you think that your population is infinite and you sampling frame is very difficult to frame, then you can go for the non-probability sampling, which we can call it as a non-random sampling. And you can think of purposive sampling. You may use the quota sampling, or you may go for snowball sampling. According to the research topic, it will determine. Pooja Mittal, you mentioned, sir, my studies on journal customer perception. So which customer perception are you taking, Pooja? Suppose you are taking the banking customer or the retail customer or the FMCG customer. So exactly, I'm not getting your query, but anyways, I'll let you know that if you're, again, if you're, you have a infinite population, then I think you can go with the convenience sampling. Convenience sampling you can go, but please try to understand one thing, that convenience sampling, these are unbiased sampling techniques. So you should be very careful while looking at the review of literature also, that what type of sampling technique has been proposed earlier in the good research papers, particularly to these kind of topics, because perception is very subjective phenomena. Okay, your perception may differ from me. Okay, so you can go with the kind of sampling, the judgment sampling also you can take, or if the respondent list is possible, then you can go with the, of course you should go with the simple random sampling, right? So these are the two queries. Then third query was from the why directional hypothesis. Directional hypothesis, generally we take I don't know the name, Punjabi Young Minds. So Young Mind, please, I would likely to tell you that we take directional hypothesis generally when we have the conceptual model, and when our study is based on the theoretical model. So if you are taking the theoretical model like UT-AUT model, TAM model, technology acceptance model, or you take any theory, uh, while choosing the constructs, okay. So, and you are taking the model, you are developing the model based on the theoretical framework, then obviously you are supposed to go with the directional hypothesis, okay. So that is one answer. And thank you. Rest of the, I think if one is considering data from two countries, yeah, Caroline, two countries means you have two categories. Two categories, country one, country two. So obviously you can go with the independent sample t-test here in case the data is normally distributed and homogeneity of variance is there between the two, independent the independent categories, then obviously you can go with the this independent sample t-test. So I think these were the important queries you had asked me. Now let us proceed to the uh, session of the day. And today's session is going to be very interesting because I am going to teach you a wonderful, very robust technique today. Very robust technique, which is called one-way ANOVA. And this ANOVA is through ANOVA you can see the effect of moderating variables. Basically, this ANOVA is used to see the effect of moderating variable. Moderating variables, as I mentioned you, they are always categorical. Always categorical. For example, gender is categorical, occupation is categorical, and the type of ice cream, type of coffee, okay, that is also a categorical. So you are going to see the effect of categorical variables on the dependent variable. So today's session is on the one-way ANOVA, and the outcome for today's session is identify the research problem and apply one-way ANOVA. And obviously I'm going to give you the demonstration how to generate SPSS sheet as per the requirement of one-way ANOVA and ability to execute one-way ANOVA with SPSS. So side by side, I'm looking at the YouTube stream also, so that I could come to know. All right. So let us now proceed to the recapitulate once with small test of you, that how many of you are clear that about the one sample independent sample t-test. Can somebody give me the answer of this question? I have taken this question that null hypothesis is always denoted by H sub 0 and two-tail alternative hypothesis H1 of the one sample t-test can be expressed as statistically. Please tell me which is the null hypothesis, A, B, or C. Which is the right option for null hypothesis? Please give me the your response, that what is the right answer? What is the right answer? Is it A, is it B, or is it C? Both A and B. Which is the right option for the null hypothesis? Yes, any response, Dr. Jaspreet? Any response by the participants?
So yes, people have started giving response. B. Janki Agrawal has shared B.
Okay, B. Okay, B is null hypothesis. Very good. Very, absolutely very right answer. Yes, the null hypothesis is that the population mean is equal to the hypothesized population mean. Population mean is always unknown. Population mean is equal to the hypothesized population mean. Very good. So B is the right answer as far as the null hypothesis is concerned, whereas the alternate hypothesis is the A option. Okay, that's fantastic. That's fantastic answer. Now, in case I'm giving you one more question to you, in case P value as computed by SPSS comes 0.245, to examine the initial difference in the salary packages between male and female MBA students. So first of all, you should understand that this is the problem of independent sample t-test. Why? Because we have two groups, that is group 1 male and group 2 female. And what do you interpret with this p-value? Initial salary package between male and female MBA students are not same. Initial salary package between male and female MBA students are same. What is the right answer? Or initial salary package of male is higher than female MBA students, or initial salary package of female is higher than male MBA students? Can anybody tell me that what is the right answer of this question? What is the right answer of this question?
So people have started sending A.
Ma'am, I'm not able to see the response. Ma'am, I'm not able to see the response, although I have opened YouTube simultaneously on my mobile phone, on my smartphone. But anyways, maybe I'm just getting the first 2-3 slides as a resource person, or I'm getting just Dr. Shweta Miglani on the
I
Zoom
think
chat.
you need to restart.
Yeah,
you need to restart, and then you will be able to see the chats.
Okay,
it might be paused as well.
Okay, anyways, chaliye, let's go ahead. So yes, what is the answer? Their answer is?
So maximum are giving answer as A.
A.
Very few are saying
A?
B, but maximum are giving as A.
Okay, A. So please try to understand, when I make a null hypothesis, I will make the null hypothesis that the male-female packages are same. Okay, this is my null hypothesis. And alternate hypothesis would be that the package between male and female are not same. So since the p-value is greater than 0.245, it means your null hypothesis accepted. When the null hypothesis accepted, it means that the package between male and female, they are same. They are same. So it means the option B is the right answer. Those who are telling me A option, please rectify themselves. Please rectify yourself. It's common sense that please try to understand the logic. When I'm making a null hypothesis, what is null hypothesis? There is no significant difference. Chalo, anyways, I'm writing like this way. There is no significant difference, because generally I have seen that researcher, they understand null means no, because I don't know why they have this in their mind that null means no. So they understand from such type of hypothesis very easily. Chalo, anyway, I use like this way. Chalo, for your convenience. There is no difference between package between male and female. This is null hypothesis. And there is a difference between male packages and female package. This is alternate hypothesis. I think it is clear to you. Now, in this particular case, p-value is greater. When p is greater, what will you fail to reject the null hypothesis. So obviously you will accept the null hypothesis. And what is the null hypothesis? That there is no significant difference in the package between male and female. If there is no significant difference, it means that initial salary package between male and female MBA students are same. So I think, is it clear to you now? I hope now you are agree with me that B is the right answer. Okay, right. So now let us move to ANOVA. So this is, I'm going to start with the ANOVA. What is ANOVA? ANOVA is made of the word ANOVA. AN means analysis, O means of, and VA means variance. So first you should understand, analysis means finding, and variance means how much it is different from the mean. The distance from the mean is called the standard deviation, and the square of standard deviation is called the variance. So how many items are near or away from the mean, that we can call it as a standard deviation, and variance is a square of standard deviation. So ANOVA generally is used to measure volatility. Even the finance students, those who are doing studies on the volatility, dispersion, spread. So in these type of studies, you can go with the ANOVA, analysis of variance. So analysis of variance is again finding the significant difference, but only the difference between independent sample t-test and ANOVA is that in an independent sample t-test, we have the two groups, whereas in the ANOVA we have the several groups. Several means several groups. Okay, so when you have more than two categories, when you are having more than two categories in independent variable, and your dependent variable is again metric data. Metric data means your interval data and your ratio data, then you are going to apply ANOVA. Please note down in your notebook in the bold letters, ANOVA can be applied only and only in the situation where your independent variable is categorical and your dependent variable is the non-categorical, means your metric data. So two conditions are there when you are going to apply ANOVA. And ANOVA is used for experimental design. This is actually an experimental design. Basically, you are going to study the effect of treatment on the you are going to study the effect of treatment on the output. Okay, so that is what your treatment you are going to use, that is for the category. Okay, now you try to understand like this, that first ANOVA is a parametric procedure. It is a parametric test, and it is used to compare several population mean. As I told you, like for example, male, female and transgender. Now you have the three categories. If you are going to study the CGPA or any example you can use, if you want to compare the satisfaction, okay, satisfaction of you can say deodorant among the age group, different age groups, okay, young, old and middle, young, old and middle, then you know that you have more than two categories, young, old and middle age. But your dependent variable is satisfaction, which you have actually measured on the interval scale from, or on the rating scale from 1 to 5 or 1 to 11 or 1 to 9. So this is a particular situation, particular example where we use ANOVA. Now I'll give you one good example of ANOVA. Let's say, suppose there are three medicines being treated for COVID-19, in the market, and there is Covaxin, there is Covishield, and there is AstraZeneca. Say for these three different categories of medicines. And we are to see that how many patients get treated with the medicine 1, medicine 2 and medicine 3. I mean, which is the best, which is the effective. So I am going to study, I'm going to compare their means. I'm going to compare their, performance of these medicines on the health of the patient. So in such type of, situation, in such type of, problem, we are going to use the ANOVA, analysis of variance, one-way ANOVA. Okay, because I am going to compare the performance of Covaxin, Covishield and AstraZeneca. Okay, so in such type of research problems, you are going to apply one-way ANOVA. So there are certain assumptions for one-way ANOVA. Please, first of all, you should have independent categories. Your number of categories, your independent variable should be categorical. That is fixed effects model, means the inferences made in one-way ANOVA are fixed to the number of categories. Means whatever the number of categories are your independent variable, your inferences would only be applicable to those categories only. That is why it is called fixed. That is why it is one of the assumption for one-way ANOVA, that is the fixed effects model. Second assumption is absolutely, as it is a parametric test, so your target population must be normally distributed. Okay, and third is that the sample should be randomly selected from the normal population. That is called an independence of error. Then fourth is homogeneity of variance. Homogeneity of variance means that the groups, the categories should have equal variance as reflected in the distribution. And most importantly, your dependent variable used as a test variable in this analysis should be measured as a continuous scale on like the Likert scale and the ratio scale, the interval and the ratio scale. So these are the 5 important assumptions for one-way ANOVA. Once these assumptions are met, so how can we ensure that whether these assumptions are met or not? So first of all, I am giving you the tips that what to do. For fixed effect model, you have to first identify whether there are distinct categories used in the experiment, number one. And in order to check the normal distribution, I have already guided you yesterday also that you need to check through graphical method by through histogram, QQ plot, PP plot, or you can also do through a box plot where you can see the outliers. And the numerical method, which I have already taught you yesterday also, that is called the KS test, KS one sample Shapiro-Wilk test. So this can be applied as a numeric method also. And you can also see the value of skewness and kurtosis also, okay, where you can also from the value of skewness and kurtosis, you can identify whether your data is normally distributed or not. Then third assumption is the independence of error. Then you must be ensured you will see the random selection of sample, which is run test. Run test can be applied whether your sample is randomly selected or not. Then homogeneity of variance, obviously you are supposed to go with the Levine test as we studied in the independent sample t-test also. We have to take the license from the Levine's test, and data scale should be that your dependent variable should be interval or ratio scale as I just mentioned you, and independent variable should be nominal. So first note down this thing. The third thing where I am putting the cursor, look at here, please note down whenever your dependent variable is interval or ratio scale or independent variable is nominal, then you can apply, then you can go with the one-way ANOVA. Okay. Now, suppose I'm taking one example of the college. Let's say there are 3 samples, there are 3 sections, section A, section B, and section C of MBA. Okay. And you know, in order to apply ANOVA, you must know that one sample should be different from the other 2. So you select a random sample from the section A, section B, and section C, and the teacher gives the test to each section. And now the teacher is going to see that how much, performance, whether the performance of these students among these 3 sections are same or different. Are same or different. If they are same, that's fine. But if they are different, then how much different are they in their performance of the test? So I have given you 2 examples right now to understand the application of one-way ANOVA. One is the academic example where you have the 3 samples of 3 sections, section A, section B, and section C of MCOM or MBA. And the teacher gives the test to each section, but now the teacher is interested to see to compare the significant difference among the performance among the students of this section A, section B, and section C of MBA. So this here we can apply the one-way ANOVA. And even also I have given you the example of COVID-19 example, where you have the 3 different categories of medicine, and you are going to compare the performance of these 3 categories of medicines on the health of the patient. Now, the patient health performance you are going to measure on the interval scale by using a Likert scale from 1 to 5, and your independent variable is the COVID vaccines, that is the Covishield, Covaxin, and the AstraZeneca. And you are going to study the compare the significant difference among these COVID vaccines on the health of the patient performance. So in such examples, you are going to apply the one-way ANOVA. And since ANOVA is a parametric test, so very common thing which I have already emphasized, In order to apply the parametric test, you should know that your dependent variable must be metric data. Metric means interval or ratio data, and there should not be outlier, and there should be a homogeneity of variance, and more importantly, sample should be randomly selected. So these are all the assumptions, as I already discussed with you. Now, what are the applications of one-way ANOVA in the marketing? There are some of the professors which are sitting over here right now, that we must understand that how can we give such projects to our students, to our MBA students, to the MCOM students, to apply one-way ANOVA in the small in their capstone projects. So you can see, like for example, I take, do the various segments differ in terms of product consumption? Various segment means the segments of the customer. Again, it is a categorical independent variable, and product consumption is a dependent, which is the metric. Okay. What is the effect of consumer familiarity on the preference for the store? What an interesting project you can give to your student, and you can apply this one-way ANOVA simply on the objective. Your objective is, let's say in your research, to study the effect of consumer familiarity on the preference of store, or on the preference of online shopping, for example. So obviously here you can go for one-way ANOVA. And how do consumers' intention to buy the brand vary with different price levels? You have a different price levels, let's say 50 rupees, 100 rupees, or 150 rupees, these price ranges. You have a different price categories, and you are going to study the big purchase intention. So here, independent variable, your price level, high, low, and medium, 3 categories, and purchase intention is your dependent variable on the Likert scale. Okay, so these are some of the marketing examples where the answers to these questions can be determined by one-way ANOVA, right? So I think I have given you the journal example, and I have already given you the marketing examples also, where you can apply the one-way ANOVA in such type of problems. Okay, so first of all, you should know, when you have these several population, when you have more than 2 population, like male, female, transgender, or you have a more than 1 category in any of the variable. For example, income, high, low, and medium. So you have the 3 different categories as independent variable, and your dependent variable is your metric data. That is very, very important condition to apply the one-way ANOVA. Now the hypothesis, all parametric tests, they are hypothesis inferential tests. So first of all, in the one-way ANOVA, you know that there are several means, several population, more than 2 populations, population groups. So you are going to frame the null hypothesis that the population mean is same in all the groups. And whereas the alternative hypothesis will be that the population mean is not same in all the groups. Okay, these are the null hypothesis and the alternate hypothesis you are going to frame. And this K means number of levels. K means number of levels which you are going to take. Okay, now once it is clear to you, let us understand one question which I have brought for you. It is very interesting case study where you can understand the experiment. I have told you ANOVA is an experimental, what we can call is a experimental test, where actually you have the 2 different types of experiment. One is the completely randomized design, and the second one is the completely randomized block design. Second is the randomized block design. So first we are going to do a completely randomized design, which is the short form is called the CRD, completely randomized design, where you are going to study the significant difference among the categories. Then it is called a completely randomized design, CDR. And suppose let's say you have conducted one study on say coffee drinks. You have a different category of coffee drinks. There is a cappuccino is there, or moscato is there, and you have one another, let's say the category of coffee, and you have conducted one survey from the 105 customers, and you have gathered the data for measuring the satisfaction among the customers, okay, among the customers, with respect to the three coffee drinks, with respect to three coffee drinks. So it is common understanding that it is a question of ANOVA. The reason being the problem, the research problem, that you are going to compare the satisfaction, okay, the satisfaction among the three categories of coffee drink. So you can write down, because your independent variable in this example is the three coffee drinks. Three means categories. The coffee drinks is a categorical. So the independent variable is categorical. It is nominal. And on the next right, the dependent variable is the satisfaction. And satisfaction you have measured on the 10-point scale, where 1 is the completely dissatisfied and 10 is the completely satisfied. This is a metric data, Likert scale data, interval scale data. So obviously you should be confident, you must be confident that, okay, we have to go with the ANOVA test. We have to go with the one-way ANOVA to apply in this particular, problem. Okay, now we are going to go with this further while framing the hypothesis. So when first you are supposed to frame the hypothesis, what will be the hypothesis? The hypothesis will be, as I just taught you in the 2-3 slides back, that you are supposed to write in this particular problem that satisfaction for quality of coffee drink is same among all the experimental groups. And the alternate hypothesis will be satisfaction for quality is not same among all the experimental groups, right? So satisfaction for quality means the quality of coffee drink. Quality of coffee drink, that is cappuccino, macchiato, and the Americano. Okay. So these are the three categories, and your satisfaction is your, the dependent variable. So you will make a null hypothesis and alternate hypothesis like this way. In case of null hypothesis, this is the statistical form of writing the null hypothesis, which starts from the H0, and this is the population mean of cappuccino, population mean of macchiato, and population mean of Americano. And then is the alternate hypothesis, where we write there. So you can understand like this way also, in a layman's sense, there is no significant difference. Null means there is no significant difference, and alternate means there is significant difference. So you can write like this way also, or you can write like this, that satisfaction for quality is not same and the satisfaction of quality is same. Once it is the null hypothesis and alternative hypothesis is being framed, so first and foremost job is to check the normality. So I will share this PPT with you all today. I have put all the process, all these steps which you are going to go to check the normality of the dependent variable. We are going to check the normality of the dependent variable. Please note down, we never check the normality of the categorical variable. I think it is already, I have told to you. So you will check first the normality through one sample KS test. I will tell you the procedure, the process, but I have written down on this box also, where you can look at these steps and easily you can do the practice of this, assessing the normality of the data. Then after the normality, you will get this output. You will get this output in your SPSS, where you will see the KS value. KS value is 0.08. I will not repeat again and again, because yesterday I also guided you the same thing to check the normality. Whenever your P value is greater than 0.05, your null hypothesis accepted, and your null hypothesis is that the data is normally distributed, and alternate hypothesis is the data is not normally distributed. But in this case, in this particular problem, your P value is 0.06. So you get 5% level of significance, which is greater than 0.05. So we fail to reject the null hypothesis. It means that we conclude that the data is normally distributed among the all treatment groups. Among all the treatment here is coffee. Treatment here is called the coffee drink. Okay. Now, next we are going to, we can also see the normality through a graphical display, as I guided you yesterday also, that we can also check the graphical display through QQ plot or through PP plot. I can also show you this one also by looking by through a hands-on experience with SPSS, but I have written the process that you will go to menu bar, then click on analyze, then click on descriptive statistics, then you click on explore, then select the quality and transfer to the dependent list, because quality is a liquor data. So obviously you are going to check the normality of the liquor data. You can't check the normality of the categorical data. It's I think you must be clear. And then you select the plots under display box and then continue and then click OK. So once it is done, you will check the graphical display of normality. Now, from this, this is called a box plot. Box plot is very fairly symmetric distribution that you have not seen any outlier in this particular graph. So we can say that yes, fairly very symmetric distribution of quality in experimental groups. So we must be confident that, okay, I am applying a very right appropriate test related to the research problem, related to the objective. Next is the homogeneity test. You know, you have to take the license from Levine also, because Levine, as Professor Levine said, okay, please, before to report the result of ANOVA, you have to take a green signal from me. Otherwise, you cannot report the results of ANOVA. So what we can do, it's okay. We will take the token from Levine by checking the homogeneity test, homogeneity of variance among the groups. So we will check the homogeneity of variance of all the categories of coffee. We have the 3 categories of coffee. So we are going to check the homogeneity of variance, okay, of the dependent variables of all the categories, okay. And we will frame also a mean plot. We will also formulate a mean plot. So once we will do this, we'll check the homogeneity test. For homogeneity test, I also guided you that your p-value should be greater than 0.05. If it is greater than 0.05, then the equal variance assumed condition is met, and then we will go with the output of the ANOVA statistics. Okay, and in order to check the homogeneity, we will click on the descriptives, homogeneity of variance test, and means plot. Means plot also we will look at. Now, once it is done, and this is once we have selected the required options, then we are going to look for the post hoc test. What is post hoc? Post hoc का मतलब होता है very simply how much difference in a layman's sense. If you really want to know difference is there, let's say you are comparing coffee category 1, coffee category 2, coffee category 3, that is cappuccino, macchiato, and the let's say the third category. But in the post hoc, you can actually do more in-depth analysis. Actually, through post hoc, you can do more in-depth analysis that how much difference is there. Up to the ANOVA, you are just getting that whether there is a significant difference among the means or not. But through post hoc, you can actually come to know that how much difference is there. How much difference is there, whether that difference is significant or not significant. So this decision you can actually get from the using a post hoc test by using a Tukey's test. Tukey is one of the great contributor. So we will select the Tukey's as a test of equal variance assumed. Okay, I will send you one paper where you will get the citation also for the Turkeys as a test of equal variance assumed. Why not we select Bonfroni, SNK, Duncan, Chaffee, and Waller Duncan? Why we are going to take only the Turkeys test? Okay, Nidhi Grover, do you have any question? Your emojicons reflect something. Can you tell me, is there any question, or actually you are getting the insights? So then is the descriptive statistics. So in the descriptive statistics, we are only going to go with we can come to descriptive is mean, standard deviation, mean, median, mode, standard deviation. They all come under the descriptives. So from this table, we can only look for, or we can take the, look at the mean of the average and standard deviation of the cappuccino, macchiato, and Americano, the coffee drinks. Then the equality of variance. This will come from the homogeneity of test, which we will do. I will show you the hands-on experience. Then you will see all these tables in the output when I will perform the test, but I have put on the slide so that you can come to know that, okay, the output will remain the same, which sir has shown through slides. Okay, so as you know, here in the Levine statistics, your significance value is 0.490, and it is more than 0.05 at 5% level of significance. Then hence we fail to reject the null hypothesis, which stated that there is equality of variance, means the variability for the two groups are equal. Now ANOVA, this is the last report of the ANOVA test, means you will report this test, this report, you will report it on your research paper in your thesis, where you are going to show this output, where you have the between groups, within groups, and you have the degree of freedom between groups and the within groups degree of freedom, and you are supposed to mention this F ratio, F value. So that is why ANOVA is also called F test. It is also called F test. So we have to report this F value, and we have to take the decision of rejection or acceptance on the basis of this significance value, that is 0.08. And 0.08 means, again, it is greater than 0.05. So you have to mention the report in the report while putting the findings. Then this is the last table which you will get in the post hoc. When you choose the Turkeys post hoc, you will get this type of output. What is this output? In this particular output, you will see the significance values, these 0.38, 0.61, 0.38, 0.06, 0.61, 0.067. So what it actually means? It means that you can see here as the P value in the cappuccino, in the Americano and cappuccino, in the in here, you can see here that P is greater than 0.05, which is 0.618. Here you can see 0.618 in case of Americano and cappuccino. I'm going to compare how much difference is there, between the Americano and cappuccino, between the Americano and macchiato. So that is why I am going to take the P value of the significance values, that is 0.618 in the Americano, and in the macchiato it is 0.387. Both the values are greater than 0.05. It means, again, we will accept the null hypothesis. We fails to reject the null hypothesis. So we can say that equal satisfaction exists for these two drinks, because the null hypothesis will be that there is equal satisfaction, and alternate hypothesis is that there is no equal satisfaction. So, but since the P values in both the categories is greater than 0.05, so you will say that equal satisfaction exists for these two drinks. Similarly, for the third pair means, like you can see here, here is also 0.61 and 0.067. Again, it is greater than 0.05. So again, you will quote in your report that yes, the satisfaction level again is equal between the this cappuccino and the macchiato drinks. Okay, so this is how you are going to go in depth. Okay, now you are able to find out the how much difference how much difference is there in among the these coffee drinks. So once it is clear, then you can also see the visually also. Visualization also will tell you, you can see this visualization where you have the mean of cappuccino, this is the mean of macchiato, and this is the mean of Americano. You can see that macchiato is having a very mean of 4.7, somewhere 4.7, whereas the mean of cappuccino is 5.6, almost, and in the Americano, the mean is 6.2. So we can easily interpret the closer means that this cappuccino and Americano, they are near to close to each other, because its average is 5.6 and this average is 6.2. Almost means they are not very near, but they are near. But if you compare the cappuccino and Americano, the macchiato is very far away because it is 4.7. So this is how you are going to take the decision from the graph also, and at last you will report the results, which I have just told you, that first you will report the KS sample test, very important, whether the null hypothesis accept or reject, and then also at last you will report the p-value, that is 0.081, which is very higher than the 5% level of significance, which infer the result that you are going to accept the null hypothesis. So we conclude that the quality of 3 coffee drinks is the same among all the treatment groups. So I think still now I have given you the process of one-way ANOVA. Now I will be going to show you the demo one by one. I'm sharing you that how we can perform this in the demonstration through SPSS. Okay, so now let us open. Now I'm going to open SPSS first. Just a moment. I am opening SPSS and I'm stop sharing of so how are you feeling? What are your observations? Observations is very important. Your observations make you more successful researcher. If you are good observer, you are a good researcher. Make it this thing on your notebook, write in your notebook that be a good researcher, be a good observer like a kids. Okay, be inquisitive, that why I'm taking this topic, why ANOVA, why factor analysis, why some students, they make the objectives and they ask the guide or supervisor, sir, can I apply correlation here? Can I apply regression here? My dear participants, research only, as a researcher, we only do 3 things. First is compare. Either you compare, either you study relationship, or you study the impact. So there are only 3 things you do in your objective. One is relationship. So relationship can be measured through correlation. Relationship can be measured through regression. When you are going to study the extent of relationship, I'm using the word extent, EXTENT. Then we are going to use the regression, and when I'm going to study the relationship, simple relationship, then I can go for the correlation. Then obviously when you have the ranks, please do such type of research papers and read some statistics books, that when your data is on the ranking method, then obviously you can go with the Spearman's rank correlation method. Spearman's rank correlation method you are going to apply. But if your data is on the Likert scale or on the ratio data, then you can apply Karl Pearson correlation method. Okay, so you can apply R means your correlation, R square is your regression, simple. R square is your regression, which is called the coefficient of determination, and R is your correlation. And so what my crux to make you understand is that please note down that in your objective, always you are either going to study to compare, or to study the relationship, to examine the relationship, or to study the extent of relationship. When you are going to study the extent of relationship, go for regression. ANOVA, when you are going to study the simply relationship, then go for correlation. When you are going to study the, compare, when you are going to compare, then obviously you are going to find out the significant difference. Then you are going to study the parametric test, then go with the one sample or the independent sample t-test, or one way ANOVA. So very simply you can take, if you have two categories, for example, abhi maine liya, I have just taken the coffee drink as a one category. If I am having the coffee price range, price level, I am having two categories. Let's say now I am having two distinct categories, participants. Say for example, coffee drink is one category and the price level of the coffee is another category. Now I can go with the two-way ANOVA. Now I am not going to apply one-way ANOVA. Now I am going to apply two-way ANOVA. The reason being because I have two distinct categories in the as in independent variable. You understand my point? So this is how you are going to take the decision. And even I can also do in the same example, I can also check the location. यार कॉफी ड्रिंक इज ओके वन कैटेगरी, बट डिपेंड करता है कि वो लोकेशन कैसी है. दैट लोकेशन विल आल्सो गिव यू मी अ सेटिस्फैक्शन. फॉर एग्जांपल, लेट्स से माय गर्लफ्रेंड लिव इन नियर टू दैट कॉफी पार्लर, so obviously it will give me more satisfaction, whether it is a cappuccino, whether it is a mojito, or whether it is a americano. I'm just giving you a just fun example to make you understand that, so that you could understand the phenomena that yes, the location of the coffee outlet, that will also give you that will also play a role in the satisfaction. So what we will do, then we can think of the and then we will use the randomized block design method. Now we will going to use randomized block design method. Okay, but this example where I'm only taking the coffee drink, only and only the coffee drink, then I'm going to use the completely randomized experiment. Completely randomized experiment. And when if I'm taking the coffee drink and as well as the coffee store location, then I would be going to use the randomized block design, because I am going to see the effect of blocks also. Blocks means the location. Okay, so let us now go with the, I think you all are excited for the demonstration. I can understand that your excitement, because जब मुझे भी बड़ी excitement होती है when I am going to learn something from somebody. Okay, and learn from anybody. Nobody is perfect in this in research. Okay, research is a journey. Research is never-ending process. You cannot be expert of music. You cannot say that that if you are reached to you are at particular level, then you say I am the finest musician, I am the finest artist. No. So similarly in the research also, you cannot say that I am the finest researcher. Research is an ongoing journey. It is a journey of learning. It is a journey of improving your personality. It is the journey of improving your your decision making, because from the research you can take good decisions, and if you do a bad research, you give a bad decisions. If you do a good research, you will give a good decisions. That is the practical application of research in the decision making. And let us now share the screen, because you all are excited, just like looking as I'm going to offer you a coffee drink. You are so excited, but anyways, I can give you coffee only through this example. Okay, so let me share the screen. Yeah. Okay, Jasprit ma'am, is the screen visible, ma'am? Dr. Saab, is the
Yes,
screen
sir.
visible?
Yes,
Fine.
sir.
Okay, ma'am. Ma'am, is the session going fine? My voice is audible? I mean, is there
Yeah,
no
perfect, sir.
voice cracking, anything? Okay, all right. Anyways, so let us first, ma'am, we have to import the data. First step is always import the data. How will you import the data? Whatever the data you have generated from the Google form, or you have punched your data through manually on into your laptop in SPS, in MS Excel. Okay, then you can import the data. How to import the data? You can import the data from here. You have import database, Excel, CSV data. CSV data is comma separated value data, text data. Then these three types of data you can use, but primarily we use Excel data or CSV data. Okay, but I have, when you have already the existing file in your system, then you can use the data like open data or open syntax. Syntax I will use tomorrow, because tomorrow I am going to teach you a fantastic technique which you will enjoy tomorrow. I'm not going to tell today, otherwise the climax will be, no, you can't enjoy. Anyways, so syntax. Okay, so what we will do, will I am having the already existing data of coffee drink, so I will open the coffee drinks file which I have. I'm going to do this practice with you. Now, once this, I think the screen is visible to you. Can I come to know how many variables are there? Yes, one question to you. Can you please tell me how many variables are there? Caroline, Rono. Caroline, can you tell me how many variables are there in this file? It seems that Caroline is from, I think, international participant. It seems, maybe it is a perception. This is perception. This example is a perceptual example. I am perceiving that Caroline is from international participant. I may be wrong. This is perception. And perceptual studies are very, very important in the marketing domain, because perception play a very, very important role in your business performance. Okay, in any of your business performance, you need to your perception is quite important. So you have three variables here. Please note down, you have three variables. Coffee is one variable, quality is second variable, and cafe location is the third variable. Always remember, these columns are called variables and rows are called observations. Observation means this one is first respondent, second respondent, third respondent, fourth respondent. Okay, these are called respondent, and on the right side it is also written 3 of 3. And you can also look at the coding also, like this one means cappuccino, this one means cappuccino. Okay, my pronunciation may be wrong, so please, I'm fond of tea, so you can use whatever the cappuccino or cappuccino, you can call it this cappuccino. Okay, and then you can see, one means cappuccino, and two means, two stand for, you can see here, macchiato, and three stand for some other coding. Okay, yes, Caroline, so my perception is right. Yes, so I'm good in perception by looking at the name. So okay, anyways, now cappuccino is, and similarly cafe location is location 1, 2, 3. So first of all, you as a researcher, first understand that this variable is categorical variable. This variable is categorical variable. Cappuccino, this is category. And again, cafe location is also a categorical variable. Location 1, location 2, location 3. This is also a categorical variable. But this quality is not a categorical variable. This quality is a rating scale, which you have used in the, you can say in 1 to 11 rating scale, 1 to 11 rating scale, and you have taken from the data. Now, once it is done, first step, what is the first step? First step is I will check the normality. How will I check the normality? Either I can go to explore, and dependent list will always be quantitative, which is the metric, and factor list, I am taking the coffee. I am taking coffee. And in the statistics, I am going to do nothing. And plots, in the plots, I am going to see the normality plot with the tests. Normality plot with the test. And click on continue and OK. Once it is OK, you can see that the output will come, where you can see the case processing summary, and descriptive, where mean, median, mode, standard deviation of all the three categories of cappuccino, macchiato, and americano. And then you can see the category wise normality. Category wise, because we check the normality of each category of dependent variable. So you can see, fantastic. This is absolutely normality. Normality is there because observed values are very much near to this line. And then we can check the normal QQ plot we have checked. Then we can check the we can also check through test of normality. We can also check through the test of normality. We can see there is in the quality, cappuccino is 0.21, macchiato is 0.17, again greater than 0.05, americano is 0.57, again greater than 0.5. So we can say that the test of normality condition is met. Test of normality condition is met. So we are confident. We are confident that our data is normally distributed. And we can also check through the even through once it is ensured from the test of normality. One another way today I am teaching you to check the normality, which is very, very easy. So what you can do, simply you go in the data sheet, in the data view, go to analyze, go in the non-parametric test and legacy dialog, and here it is written one sample KS. Click on the one sample KS and write here quality in the quality and just look at OK. Even you can check the normality like this way also, where you have got the 0.061, again it is greater than 0.05. So you can check the normality of the independent variables. Okay, normality of the dependent variable of all the categories. Okay, so once the normality is clear to you, now the next step, as you know, we have to seek the license from Levine. So what we will do, we will go to compare means. Compare means, in the compare means, we are going to go to one-way ANOVA. Here it is written one-way ANOVA. Click on one-way ANOVA and tick here the dependent list, and in the factor you are going to take coffee. In the factor you are going to take coffee. Once it is done, you are going to click on options. In the options you are going to click on homogeneity of variance test. Homogeneity of variance test, or even you can click on descriptives also if you want to study descriptive statistics also, and click on means plot and continue. Once it is clicked on, you will come to know these are the descriptives of cappuccino, macchiato, and americano, and this is the test of homogeneity of variance. So your null hypothesis, that equal variance assumed, and alternate hypothesis, equal variance are not assumed. But we must be happy that in this particular case, our p-value is 0.490, which is greater than 0.05. When it is greater than 0.05, then equality of variance assumed. Equality of variance assumed because null hypothesis accepted. Why? Because your null hypothesis is that there is no significant difference, which means that equal variance assumed. Then after this getting the license from Levine, we are now going to report the ANOVA results, the final output, this particular output where we have the degree of freedom 2,102, where F is 2.571, and your p value is 0.08, which is again greater than 0.05, which means that null hypothesis accepted, and we fail to, or you can write that we fail to reject the null hypothesis. So we can say that there is no significant difference. It means the satisfaction level in this particular problem, the satisfaction level of all the coffee, three types of coffee, that is same. So that is called that we can call it that now we can understand the application of ANOVA finally. And one thing which has been left deliberately, that we have not seen the post hoc. So in order to check the post hoc, nothing to do, everything would be same, only you need to go to the post hoc. In the second, it is written post hoc. Click on post hoc and right here Tuckies. Click on Tucky and continue. Once you will continue and click on OK, you will find that your post hoc test results will also come, and you can see here. This is the multiple comparison. This is the multiple comparison which I have shown you through slides also. Through slide also, which I have shown you. These are the multiple comparison where I have shown you how much difference is there. So there is no difference as p-value is greater than 0.5. So there is no difference in between the macchiato and Americano or cappuccino and the macchiato. Okay, and you can also look at the means plot. In the means plot also you can look at this is the mean plot which I have shown you, where the macchiato, the mean is just a moment. Yeah, so 4 point something 6, where the cappuccino and Americano, they are very much related, near to as far as the mean is concerned. So this is the application of the one-way ANOVA at one go, that how to implement and how to execute the one-way ANOVA in SPSS. Any question you have, you can put in the chat box. Okay, once again I am showing you the steps. Once again I am just repeating the steps, those who have been left. Okay, it is very simple step, that first of all you need to import the data set, and once the data is imported, then first you will check the normality of the the dependent variable. So you will click on descriptive statistics, go and explore, and in the explore you will choose the quality in the dependent list, and factor is always categorical, so you will take coffee here, and then click on the plots. In the plot you will select the stem and leaf, by default factor level together, and normality plot with the test you will select here. And once it is selected, once it is chosen, then you will click on continue, and once it is continue, you will get the results, where you can see the output, where you have the case processing summary. Case processing summary means that there is no missing value, and from the descriptives you can take certain decisions to report in your report project, mean, median, standard deviation, like those things. And normality you will check through the KS test. All the values are greater than 0.05, then we can say that the data is normally distributed, because as I mentioned you that when p is greater than 0.05, the normal distribution. Once the normality is checked, then again, very simple, again go to the step number 2. So first step is write down the steps. There are 3 steps, there are 4 steps. Write down the first step. The first step is check the normality. Second step is check the homogeneity of variance. The third step is check the what is the third step? Execute the ANOVA. Third step is apply the ANOVA. Okay, and fourth step is post hoc, that is multiple comparison. And once it is done, so once the normality is checked, then go to the compare means and click over here one-way ANOVA. And first you need to check the homogeneity of variance test. So don't forget to click it. Always click over here to check the homogeneity of variance, because this is the second assumption. This is one of the second assumption to apply one-way ANOVA. So you will click on homogeneity of variance, means plot, and descriptive, from where you can come to know about the the normality. So normality is also very good, because all the values like based on mean, you have to check only on the based on mean, because it is parametric test. So we are not concerned with the median, we are going to only concerned with the based on mean. And the based on mean, the dependent variable normality is 0.490 p-value, so it is greater than 0.05, so the data is normally distributed. The homogeneity of variance is, the condition of homogeneity of variance is met because p value is greater than 0.490. And once it is okay, then you can go with the ANOVA. And nobody has asked me this question. Suppose, sir, if the normality condition is not met and your homogeneity of variance condition is not met, then what we will do? Nobody has asked me this question till now. And anyways, I will let you know that in case your p value is less than 0.05 in case of normality, or in the homogeneity of variance also both the conditions are not met, then immediately you will take the decision to apply non-parametric test. Immediately you will take the decisions that okay, you go with the non-parametric test, and in the non-parametric test the substitute of one-way ANOVA is KW H test. H test is the Kruskal-Wallis H test. Kruskal-Wallis H test is the substitute of one-way ANOVA. So you are not supposed to put your hand on the forehead. Okay, what should I do? You have the substitute to go with the non-parametric test, that is KWH test. And suppose you are applying independent sample t-test, and independent sample t-test, again your normality is not met, or your homogeneity of condition variance is not met, then you have also the substitute of independent sample t-test, that is called the Mann-Whitney U test. Mann-Whitney U test you can apply instead of the independent sample t-test. Is that clear to you? And in case if you think that okay, my dependent variable is also nominal and my independent variable is also nominal, then what should I do? For example, let's say you are going to study the say for example the coffee drink, the type of coffee drink, and the gender, and the type of gender. Means Americano is more preferred by male people, or the cappuccino is more preferred by the female people. So in this type of problem, when your dependent and independent variables both are categorical, then you have the king of non-parametric test which you can apply is called the chi-square test. You can go with the chi-square test, you can apply. Okay, you can apply the cross tabulation method. It is also called cross tab method, chi-square method, where your dependent is also categorical and your independent is also categorical. In those situations, you can go with the chi-square test. So I have given you all the situations where you can come across with the while applying the this one-way ANOVA. Okay, so this is chi-square test. Yes, Dr. Mitali Deka. All time use H test when the case of non-parametric. Yes, Riddhi, suppose your objective is, you try to understand your objective is to compare the significant difference. So obviously then only you can if these conditions are not met, then you can go with the KWH test. Okay, your question is very good. You have deleted this question. I don't know why, but it was very wonderful question, Riddhi Gupta. Anyways, be confident when you are asking the question. Don't worry. Okay. So always ask question. Asking the question is a good sign that okay. There are two ways. Either you are more clear, then you don't ask the question, or you are not at all clear, then you don't ask the question. Okay. So that is only the situation when you ask the question and when you don't ask the question. Okay. But anyways, any other doubt, any other thing? Now, in case, for example, I'm repeating one more process through in this particular case. Suppose I am going to study the two categories like cappuccino and location. One. Then what should I do? Then I will go to analyze. Then I will use a journal linear model. And click on the univariate. And here I am going to take as a quality as a dependent variable. And I will take the coffee and the cafe location in the fixed factors. And then I will be going to use plots. In the case of plots, like for example options, in the options I am going to use the homogeneity of the test, descriptives. So these things you can do when you are going to see that this is the randomized block design method. This method is randomized block design method, which I am right now telling you. I'll send you the same, I mean, this example also. And here you are going to take the coffee and coffee location to the display means, and then click on continue and okay. Now this is the univariate analysis of variance descriptive. This is called the uh, randomized block design method, where you have the but don't get confused. I think this will be much today otherwise. So these are the uh, effect of location. Now you are also getting you will get the effect of locations also, that how location is actually getting you. Now you are going to go to apply, and sorry, one thing is missing, which is let me see what is yeah. So click on F test and then click on continue. Yes. And okay. So now you are going to look at this this particular example for the, when you are also going to see the effect of location also. But anyways, I think you are now clear with the one-way ANOVA, that how to use one-way ANOVA, and what is the application of one-way ANOVA, and where do we use one-way ANOVA. Now let me again share the PPT. So now I am telling you the discriminant analysis. Now the discriminant analysis is the opposite of one-way ANOVA. How it is opposite? Whenever you will be having the dependent variable categorical and independent variable when it is a metric, then you are going to apply the discriminant analysis. This is the only difference between ANOVA and discriminant, that in case of ANOVA, as you know, that your categorical variable is independent variable and your metric data is your dependent variable. Whereas in case of discriminant analysis, what is there is that your independent variable is metric data and your dependent variable is a non-metric data. For example, suppose one of my researcher, let's say she is doing to study on MSME's performance, MSMEs in Punjab, to know whether they are they adopt the online shopping or they do not adopt online shopping, e-commerce adoption among the MSMEs of Punjab, say for example, and I am going to study that whether they adopt the online shopping or they do not adopt the online shopping. So it is a case where you are going to predict, whether you are going to classify, okay, whether they are going to adopt or they are not going to adopt. Whenever your dependent variable is categorical, where you are going to predict true or false, whether you are going to produce happen or will not happen, when you are going to predict in the future period of time, okay, whether the student is going to get admission or not getting admission. So you here in such type of situation, you can apply discriminant analysis. For example, let's say if I have the data set of students, I have the student data of CGPA or CA, or you can say marks. This is a metric data. You know, it is a metric data, continuous data, and I am going to predict that whether the student will get the placement or not placed. Will he place or not place? So then we can call it as, then we can use the, in such type of situation, we can use the discriminant analysis. Or in the banking industry, suppose the bank manager is interested to issue the credit cards based on the track record of the customers. He is having a CIBIL score, he is having, you know, the income of that customer, he is having the, let's say for example, the age of the customer in the ratio data, but he is going to predict whether that bank should issue the credit card to a particular customer or not, whether that customer is a risk-full customer or whether that customer is a risk-free customer. So now you are going to predict, you are going to classify. So in this particular type of, you know, research problems, you are going to apply the discriminant analysis. So I am going to share some of the methods of discriminant analysis, that in case of discriminant analysis, how it is different from ANOVA. Discriminant is also called logit analysis. It is different from ANOVA only in terms when your dependent variable in case of ANOVA is metric, whereas in case of discriminant analysis, your I mean, the dependent variable is categorical in case of discriminant. In case of ANOVA, your independent variable is categorical, whereas in case of discriminant, it is always metric. So I think two clarities which I'm giving you through ANOVA today, that there is difference between discriminant and ANOVA, but the difference is such a way that you can easily recall, okay, whenever your conditions are reverse, means your dependent variable is categorical, independent is metric, go with discriminant and logit analysis. But if your dependent variable is metric and independent variable is categorical, then you can go with the ANOVA. Yes, Ottoman Zuma, you take the decision to reject or accept on the basis of significance value. Like in case here it is 0.74. 0.74, Ottoman Zuma, that it is greater than 0.05. And the decision rule is that when P is less than 0.05, we reject the null hypothesis. And if it is greater than 0.05, then we fail to reject the null hypothesis and we accept the null hypothesis. Okay, so absolutely does the difference tell the magnitude of acceptance of rejection? Because in both the cases, Ottoman, your P value is 0.74, significance value is 0.74, 0.56, so it is greater than 0.05. So obviously you fail to reject the null hypothesis. You fail to reject the null hypothesis and you simply accept the null hypothesis. But generally we don't write in the report writing accept the null hypothesis. We don't write like this way. It is a wrong way. Always write, since P value is greater than 0.05, that is 0.746, so we fails to reject the null hypothesis. Is that clear, Ottoman Zuma? And chi-square test measures the goodness of it. Could you please elaborate on it? Yes, I will definitely do this session also, Neha, on chi-square, on the non-parametric test. So we will have the understanding over there. Yes, it measures the goodness of it. Yes, absolutely. And any other question you have, please, you can write down. So anyways, let's go to suppose, for example, I have given you the example of HDFC Bank, who is going to screen the applicants and classify the customer as low risk or high risk. So obviously here you are going to apply the discriminant analysis, because you are going to classify the customer either in the low risk or high risk. Whenever you are going to apply for discriminant analysis, in the analysis part you have it is written over in the drop down discriminant analysis. So you click on it and select. Now in this case your dependent variable is categorical and your independent variable is metric. So I will show you just a demonstration that how you are going to do this test. I'm just sharing in a last 5-10 minutes we have. So let me share the screen with you. It is very interesting analysis, discriminant analysis. Just give me a moment of time. Just a moment. Oh, sorry. Okay, ma'am, is the screen visible to you? Can somebody tell me that screen is visible?
Yes, sir.
Anna? Yes. So I will take one file which is there with me already. Let me open to downloads. And the name of the file is discriminant. Let me open the file. There are so many files, so I'll have to find the appropriate file. Okay. Right. So this is, I think, the file which I'm going to use. Yeah, exactly. Now you can see you have this is your categorical, that is risk, high risk or low risk. High risk and low risk is now your category, your dependent variable, and these are your independent variable. Now this is the problem where you can apply the discriminant analysis very easily. Just you go to in the classify, step number analyze, classify, and in the classify you will click on discriminant. It is very simple process, the very simple test, and which you can do wonderful meaningful insights, and it is just the opposite of ANOVA. That is why I took that you should understand easily, because discriminant is just the opposite of ANOVA. Okay, so you will click on discriminant. Now here reverse, here you will put the all the your dependent variable would be a risk of default, and all your independent variable, which is metric, will come under the independent. And here you will also define the risk. Risk means one means low risk, or two means high risk, and then continue, and then click on statistics. In the statistics, we are going to choose some of the descriptives like the mean, or we can also look at the unstandardized coefficient. So because we can determine the discriminant equation, so coefficients are the loading, so we can determine the equation, and here we can also check the equality of variance within group. Covariance should be also there, so we will check it, continue, and then click on OK. Once you will click on OK, so you will have this. First is the case processing summary, and here you are getting the mean of low risk customer, high risk customer, and then most importantly you are going to quote in the you are going to report in the discriminant analysis as the eigenvalue. Eigenvalue should be greater than always 2. It is always 2. It should be greater than 2, because it is a good indicator. When it is greater than 1, it means your discriminant technique is absolutely wonderful. You are going to applying, you can go with a discriminant analysis. And Wilks lambda is a bad fit, so it must be close to 1. It must be close to 1. So it is it is 0.3. It must be close to 0 to 1. So it is 0.3. So again, it is fine that you are, and these are the coefficients you are getting. Age, this is 0.924, monthly income 0.775, and number of years of married life. Okay, now at last you are going to report, which is very important, is the which you are going to report in the discriminant analysis. That is let me just open it. Yeah, this is the coefficients. These are the canonical discriminant function coefficient. Like you have to derive a equation y is equal to a plus b1 x1 plus b2 x2 and plus b3 x3, as like you make a equation. So you will create a discriminant equation where y is your dependent is equal to, this is constant, which is minus 10.003 plus age multiplied by 0.246 plus monthly income multiplied by 0.803, because these are the coefficients, and plus multiplied by number of years multiplied by 0.085. If your calculation is in negative, if it is negative, it means high risk customer. If the answer is in positive, it will be a low risk customer. Now I can show you through the screen also, so that you could able to look at the output through this slide, where you can come to know that this is Wilks lambda is better. Lower Wilks lambda is always better. Higher eigenvalue is always better. Then this is the process which I have shown to you just now, what you have done through the process. Now in the last, you are going to see this classification matrix, where you can see that these two, they diagonally these two type of low risk customers, they are actually accurately predicted by the algorithm that he's a low risk, and the algorithm also predict that person is a low risk. And similarly, in case of high risk, they are accurately predicted, but on the right diagonally, they are wrongly predicted by the algorithm. So this one is actually high risk customer, but the algorithm predicts that it is a low risk customer. So that is why it is written over here that 94.4% this model actually classifies the case correctly classified. And then lastly, you are going to create the equation which I have told you like this way: y is equal to minus 10.003 plus 0.2456, age plus 0.008, income plus 0.08465 into years of marriage. This is discriminant function equation. Now, if I ask you the problem, okay, Mr. X, if your age is 40 years and your income is 25,000 per month and you're married for 15 years, then can I issue a credit card? Then you can apply these values into this formula, this function, and you can classify whether that is a high risk customer or that is a low risk customer. Should I issue the credit card or not issue the credit card? So these are some of the live example where you can apply the discriminant analysis, and discriminant technique is just the opposite of ANOVA. So that's what I have thought to take you to this discriminant analysis in the same day, so that you could have the sense of the difference between the ANOVA and the discriminant analysis. So thank you very much. We should be very, very particular to the time schedule. So that's it. Over to you and ma'am, please.
Anji sir, thank you so much, sir, for this wonderful session. You have really explained this complex technique called ANOVA in a very simplified manner. Thank you so much, sir. I would like to share 2 lines.
Thank you, ma'am.
That I think, Anji, that I think best suits you best, and I hope everybody will agree. कहीं गुम थे ज़माने में हम, कहीं गुम थे ज़माने में हम, पर हमारे काम ने हमें सूरज बना दिया. कहीं गुम थे ज़माने में हम, पर हमारे काम ने हमें सूरज बना दिया. गुण तो पहले से ही थे, पर मेहनत ने गुणों का सागर बना दिया. गुणों का सागर बना दिया. And we are lucky to learn from you, sir.
It is.
Thank you, sir.
Yeah, this is applicable to everyone. This is applicable to everyone, to all the participants, to the organizers, and to the every every supporting persons who are actually managing this FDP. That's fantastic. This is applicable.
Thank you so much, sir.
Okay, thank you, ma'am.
Thank you, sir. Thank you so much to all the participants. Thank you, one and all. Looking forward for tomorrow's session.
All right. All right. Thank you. Thank you, ma'am. Thank you, Dr. Jasprit, ma'am. Thank you.
Thank you.
Okay.